Effective November 1st, 2006, Section 2704 of the Florida Building Code and Section 3303 of the Florida Residential Code were amended to include specific requirements for metal framing members. The amendment states that metal framing members must be bonded to the equipment grounding conductor for any circuit that might energize the framing. This bonding ensures that in the event of a fault, the metal framing will not become energized, reducing the risk of electrical shock. The size of the equipment grounding conductor used for this bonding must be determined in accordance with the National Electrical Code, specifically Table 250.122. This table provides guidance on the appropriate size of the grounding conductor based on the size of the overcurrent protective device, such as a circuit breaker or fuse protecting the circuit. The code also permits the use of a grounded metal outlet box attached to the framing as a means of satisfying this bonding requirement. This means that if a metal outlet box is securely attached to the metal framing and is properly grounded, it can serve as the bonding point for the framing. To understand the implications of this code change, it's crucial to delve into the specifics of equipment grounding conductors and their role in electrical safety. Equipment grounding conductors provide a low impedance path for fault current to return to the source. This low impedance path facilitates the rapid operation of the overcurrent protective device, such as a circuit breaker, which quickly de-energizes the circuit and minimizes the duration of any potential shock hazard. Without proper equipment grounding, a fault current might travel through unintended paths such as building steel or plumbing, increasing the risk of electrical shock and fire. NEC Table 250.122 is a critical reference for determining the correct size of the equipment grounding conductor. The table correlates the size of the overcurrent protective device with the required size of the grounding conductor. For example, if a circuit is protected by a 20 amp circuit breaker, Table 250.122 specifies the minimum size of the equipment grounding conductor that must be used. It is vital to consult the most current version of the National Electrical Code to ensure that the correct values are being used, as codes and standards are subject to change. The allowance for a grounded metal outlet box to serve as the bonding point provides a practical and convenient method for complying with the metal framing grounding requirement. The outlet box must be securely attached to the metal framing to ensure a reliable electrical connection. The outlet box itself must also be properly grounded, typically through a connection to the building's grounding electrode system. This grounding electrode system provides a connection to the earth, which helps to stabilize the electrical potential of the system and further reduces the risk of electrical shock. When installing a grounded metal outlet box for this purpose, it's important to ensure that all connections are tight and secure. Loose connections can create resistance in the grounding path, which can impede the flow of fault current and compromise the effectiveness of the grounding system. It's also crucial to use appropriate connectors and fittings that are listed and labeled for the specific application. Listed and labeled products have been tested and certified by independent testing laboratories to meet applicable safety standards. The requirement to bond metal framing members to the equipment grounding conductor applies to all types of metal framing, including steel studs, metal joists, and metal roofing. It is essential to carefully inspect all metal framing components to identify any potential grounding hazards. Any metal framing that is not properly bonded to the equipment grounding conductor should be corrected immediately. Failure to comply with these metal framing grounding requirements can result in serious electrical hazards. In the event of a fault, energized metal framing can pose a significant shock risk to anyone who comes into contact with it. It can also increase the risk of fire, as fault current can generate heat as it flows through unintended paths. Proper grounding is a fundamental principle of electrical safety. It is essential to understand the requirements of the National Electrical Code and the Florida Building Code to ensure that electrical systems are installed and maintained in a safe and reliable manner. Always consult with a qualified electrician when working on electrical systems. A qualified electrician has the knowledge, skills, and experience necessary to perform electrical work safely and in compliance with applicable codes and standards. When dealing with electrical systems, safety must always be the top priority. Never take shortcuts or compromise on safety. The consequences of electrical accidents can be severe, including serious injury, death, and property damage. Remember to always energize circuits before working on them. Use appropriate personal protective equipment, such as rubber gloves and safety glasses. And always double-check your work to ensure that it is safe and correct. The proper bonding of metal framing members to the equipment grounding conductor is a critical aspect of electrical safety. By following the requirements of the National Electrical Code and the Florida Building Code, you can help to ensure that electrical systems are installed and maintained in a safe and reliable manner. The key takeaways are these: firstly, metal framing members must be bonded to the equipment grounding conductor. Secondly, the size of the grounding conductor must be determined according to NEC Table 250.122. Thirdly, a grounded metal outlet box attached to the framing is permitted. Fourthly, always consult with a qualified electrician. Fifthly, safety is paramount when working with electrical systems. Understanding the specifics of Table 250.122 requires further explanation. This table, found within the National Electrical Code, dictates the minimum size of the equipment grounding conductor based on the rating or setting of the overcurrent protective device in the circuit head of the equipment. The table provides a clear correlation between the amperage rating of the circuit breaker or fuse and the required ampacity of the grounding conductor. For example, a 15 amp or 20 amp circuit typically requires a 12 American wire gauge copper grounding conductor, while a 30 amp or 40 amp circuit may necessitate a 10 American wire gauge copper grounding conductor. Larger circuits with higher amperage ratings require correspondingly larger grounding conductors to ensure adequate fault current carrying capacity. It's crucial to remember that Table 250.122 specifies the minimum size of the equipment grounding conductor. In some situations, it may be necessary to use a larger grounding conductor to meet specific design requirements or to provide enhanced safety. Factors such as the length of the circuit, the type of wiring method used, and the potential for harmonics may influence the selection of a larger grounding conductor. In addition to sizing the equipment grounding conductor, it's also important to ensure that it is properly installed and connected. The grounding conductor must be securely connected to the metal framing members using approved connectors and methods. The connections must be tight and corrosion resistant to ensure a reliable electrical bond. The path of the grounding conductor must be as short and direct as possible to minimize impedance. Sharp bends and unnecessary loops in the grounding conductor can increase impedance and reduce its effectiveness. When using a grounded metal outlet box as the bonding point for the metal framing, it's essential to ensure that the box is securely attached to the framing and that the box itself is properly grounded. The outlet box must be listed and labeled for grounding purposes, and it must be connected to the building's grounding electrode system. The grounding electrode system typically consists of a ground rod, a ground ring, or a connection to the building's metal water pipe. The purpose of the grounding electrode system is to provide a low impedance path to earth, which helps to stabilize the electrical potential of the system and further reduce the risk of electrical shock. The connection between the outlet box and the grounding electrode system must be made with a continuous unbroken conductor. Splices and joints in the grounding conductor can increase impedance and compromise its effectiveness. When working with metal framing, it's important to be aware of the potential for galvanic corrosion. Galvanic corrosion occurs when two dissimilar metals are in contact in the presence of an electrolyte, such as moisture. The more active metal will corrode, while the less active metal will be protected. To prevent galvanic corrosion, it's important to use compatible metals and to isolate dissimilar metals from each other. For example, when connecting copper grounding conductors to steel framing members, it's best to use galvanized steel connectors and to apply a corrosion-inhibiting compound to the connection. It's also important to inspect metal framing systems regularly for signs of corrosion. Any corrosion should be addressed promptly to prevent further damage and to ensure the integrity of the grounding system. In addition to the requirements for metal framing, the Florida Building Code and the National Electrical Code also contain specific requirements for grounding other metal parts of a building, such as metal piping, metal ductwork, and metal equipment enclosures. These requirements are designed to ensure that all metal parts of a building are properly grounded, which helps to minimize the risk of electrical shock and fire. The requirements for grounding metal piping and ductwork are similar to those for metal framing. The metal piping and ductwork must be bonded to the equipment grounding conductor using approved connectors and methods. The connections must be tight and corrosion resistant to ensure a reliable electrical bond. The path of the grounding conductor must be as short and direct as possible to minimize impedance. Metal equipment enclosures, such as electrical panels, motor control centers, and transformers, must also be properly grounded. The grounding connection must be made to the enclosure's grounding terminal, which is typically located inside the enclosure. The grounding conductor must be sized according to NEC Table 250.122, and it must be connected to the building's grounding electrode system. When installing electrical equipment, it's important to follow the manufacturer's instructions carefully. The manufacturer's instructions will provide specific guidance on how to properly ground the equipment. It's also important to inspect electrical equipment regularly for signs of damage or wear. Any damaged or worn equipment should be repaired or replaced promptly. In addition to the specific requirements for metal framing, piping, ductwork, and equipment enclosures, the Florida Building Code and the National Electrical Code also contain general requirements for grounding electrical systems. These general requirements cover topics such as the types of grounding electrodes that are permitted, the methods for connecting grounding electrodes, and the requirements for ground fault protection. It's essential to be familiar with these general grounding requirements to ensure that electrical systems are installed and maintained in a safe and reliable manner. Ground fault protection is a critical aspect of electrical safety. Ground fault protection devices, such as ground fault circuit interrupters, are designed to detect small ground faults and to quickly de-energize the circuit. Ground fault circuit interrupters are required in many locations, such as bathrooms, kitchens, and outdoor areas, where there is a high risk of electrical shock. Ground fault protection can also be provided by a ground fault relay, which is typically used in larger electrical systems. A ground fault relay monitors the current flowing in the grounding conductor, and it trips the circuit breaker if it detects a ground fault. Proper grounding is an essential element of electrical safety. By following the requirements of the Florida Building Code and the National Electrical Code, you can help to ensure that electrical systems are installed and maintained in a safe and reliable manner. Always consult with a qualified electrician when working on electrical systems, and always prioritize safety. Let's discuss some practical examples of how these code requirements apply in real-world scenarios. Firstly, consider a commercial building with steel stud framing. The electrical contractor is responsible for ensuring that all of the steel studs are properly bonded to the equipment grounding conductor. This can be achieved by connecting a grounding conductor to each stud using approved connectors and methods. Alternatively, the contractor can use grounded metal outlet boxes attached to the studs as the bonding points. In this case, the outlet boxes must be securely attached to the studs, and they must be properly grounded to the building's grounding electrode system. Secondly, imagine a residential home with metal plumbing. The plumber is responsible for ensuring that the metal plumbing is properly bonded to the equipment grounding conductor. This can be achieved by connecting a grounding conductor to the plumbing using approved connectors and methods. The grounding conductor must be sized according to NEC Table 250.122, and it must be connected to the building's grounding electrode system. Thirdly, think of an industrial facility with metal ductwork. The HVAC contractor is responsible for ensuring that the metal ductwork is properly bonded to the equipment grounding conductor. This can be achieved by connecting a grounding conductor to the ductwork using approved connectors and methods. The grounding conductor must be sized according to NEC Table 250.122, and it must be connected to the building's grounding electrode system. Fourthly, picture a data center with numerous metal equipment enclosures. The electrical contractor is responsible for ensuring that all of the equipment enclosures are properly grounded. This can be achieved by connecting a grounding conductor to the grounding terminal inside each enclosure. The grounding conductor must be sized according to NEC Table 250.122, and it must be connected to the building's grounding electrode system. These examples illustrate the importance of understanding and complying with the metal framing grounding requirements in the Florida Building Code and the National Electrical Code. Proper grounding is essential for electrical safety, and it is the responsibility of all contractors and electricians to ensure that electrical systems are installed and maintained in a safe and reliable manner. In conclusion, always remember to prioritize safety when working with electrical systems and never hesitate to consult with a qualified professional if you have any questions or concerns. The Florida Building Code, Section 2704, and the Florida Residential Code, Section F3303, both mandate that metal framing members be connected to the equipment grounding conductor. The National Electrical Code, specifically Table 250.122, dictates how to size the grounding wire appropriately. A grounded metal outlet box affixed to the framing can serve as a permitted method of achieving this connection.